Triangles can be classified according to their side lengths, and you may already be familiar with equilateral, isosceles, and scalene triangles. However, triangles can be further investigated by looking at the angle properties or angle theorems that help us to determine the angles on both the inside and outside of a triangle. To begin with, let's talk a bit about what interior and exterior angles are. An interior angle is an angle formed on the inside of a polygon, and a polygon is simply just a shape. And an angle formed on the inside of a polygon happens when you have two sides that meet at a vertex or at a corner. So in a triangle in particular, because a triangle has three sides to it, there will be three interior angles, so one located at the inside of each corner. An exterior angle would be the opposite. It is an angle formed on the outside of a geometric shape, and you get these exterior angles by just extending one of the sides. So for instance, you can see here that from each corner of the triangle, there's been a little bit of a line segment that's been drawn and extended out or coming out of each corner. And by doing so, you get three exterior angles. So you would have an exterior angle out here in this top corner, you have an exterior angle down here, and you have an exterior angle out here. There are three different angle theorems that apply to triangles and specifically have to do with interior and exterior angles. First, we are going to review what those theorems are, and then we will take those theorems and apply them to some calculation questions. The first theorem is what we call the interior angle theorem for a triangle. And this simply tells us that the sum of the interior angles of a triangle is 180 degrees. So simply put, if you were to take each of the interior angles, remember there are three interior angles in a triangle, and if you were to add them up together, the sum would always be equal to 180 degrees. So every kind of triangle, whether it's equilateral, isosceles, or scalene, the angles on the inside will always add up to 180 degrees. The next theorem is one exterior angle theorem that we can encounter or use for a triangle. And it tells us that the exterior angle, or one exterior angle, can be equal to the sum of the two opposite interior angles. So here I have a picture of a triangle. And from the vertex located at corner Z, we've extended out this line segment in order to create an exterior angle. So let's call this exterior angle, angle Z. So in order to figure out angle Z, if I know the measurements of the two opposite interior angles, so that would be something like angle X and angle Y, if I add together angle X and Y, that will be equal to angle Z. So if you have the two opposite interior angles, you can simply add them together and come up with the measurement of the outside exterior angle. And the third and final angle theorem for triangles also has to do with exterior angles. And it tells us that the sum of all three exterior angles of a triangle will always be equal to 360 degrees. So here I have a picture of a triangle. Okay, each vertex or vertex has been extended outwards to create an exterior angle. And the exterior angles are marked with letters. So we've got exterior angle X, exterior angle Y, and exterior angle Z. If I were to add all three of these angles together, the total would give me 360 degrees. So we know what the sum of the interior angles should be equal to. So the inside angles will always add up to 180, but the exterior outside angles will always add up to 360 degrees. So now we're going to go through a couple of different practice questions and calculate both interior and exterior angles of triangles. Now, one of the good things about questions like this is similar to questions that you would see with angle theorems, there are lots of different ways that you can solve for both interior and exterior angles in triangles. You can use a combination of different angle theorems, ones that we know about triangles like we just discussed, or previous ones that you've learned about, so things like alternate angles, corresponding angles, opposite angles, supplementary angles. All of those angle theorems can also be applied here if they are valid. So as much as possible, I'm going to try to show you multiple ways to come up with the correct answer. And again, it's going to be your personal preference on how you choose to come up with your final answer. So in our first question, we're asked to determine the exterior angle, angle TUY. So angle TUY is actually this exterior angle located here, and it's actually been marked for us very nicely with this question mark. So this is the exterior angle that we are asked to solve for. Now, there is kind of what I like to say is the quick way to solve this, and then there is a bit of a more longer solution, but the longer solution will obviously also get you to the correct answer. I'm going to show you both. One quick method uses one of the actual angle theorems for triangles, and the second, longer, if you want to call it the longer method, uses a little bit of both angle theorems for triangles plus some previously known angle theorems, for example, like supplementary angles. So the quick way to figure this out would be to recognize that this exterior angle that we're looking for, well, we've been given information about the two interior opposite angles from this exterior angle. And one of the exterior angle theorems that we talked about previously states that you can take these two angles and add them together, and that will give you this exterior angle. So as long as these two interior angles are opposite or across from this exterior angles, then that theorem will apply. So to find angle TUY, we can simply add together 70 degrees plus 50 degrees, which would give us an angle measurement of 120 degrees. So that would be the shorter, quicker way or quicker method to solve for the angle. Another way that you could choose to do this would be in 2 steps. So the first thing you could decide to do is figure out what is the missing third interior angle from this corner here. So let's call this angle U. So we know that the inside of a triangle, all 3 angles should add up or total up to 180 degrees. So I already have 2 out of 3 angles. So to figure out the leftover or the third missing angle, I can simply just subtract out these angles from 180 degrees. So I'm going to call this method number 2. And I've written out my calculation. So to find angle U, that third interior angle, I'm just going to subtract from 180 the 2 other interior angles that were given to us, and that would give me an angle measurement of 60 degrees. So this interior angle here is 60 degrees. So now to calculate the exterior angle, what I do know is that angle U, the 60-degree angle we just calculated, plus this exterior angle, these 2 side-by-side angles are found or located on a straight line. And I know that angles on a straight line together need to add up to 180 degrees. They are supplementary to each other. So in order to figure out this exterior angle, I can just subtract the 60 degrees from 180 degrees, and that's going to give me the exterior angle. So to find exterior angle TUY, I can simply just do 180 minus 60, which gives me 120. So you can very clearly see that it doesn't matter which method you choose to use, you still get the same answer of 120 either way. In our next question, we are asked to determine angle U. Now, angle U is this interior angle located in the top corner of the triangle. Now, in terms of what information is given to us, we are given angle T, which is 50 degrees. That is another one of the interior angles. And we're also given this exterior angle. So we could call this, for example, angle RVU. That's this exterior angle located out here. So what you could do, again, is choose to do the quick method, the short method, or a longer two-step method. I'm going to show you both, but we'll start with the shorter method first. So what I see here is that I have an exterior angle of 120, and then across or opposite from that exterior angle, I have my two interior angles. So we can actually use the theorem that we used in the previous example, because I know that if I take angle U plus angle T, that should be equal or add up to 120, this exterior angle. So what I'm going to do is kind of build myself a little bit of an equation, and I'm going to use that equation to solve for angle U. So I know that angle U plus angle T has to equal 120 degrees according to that exterior angle theorem. So we don't know what angle U is, but we do know that angle T is 50 degrees. And it's all equal to 120 degrees. So this is a simple equation to solve. We have one unknown variable, the angle U, that we have to solve for. So to solve for this, I'm simply just going to take this 50 degrees and I'm going to bring it over to the right-hand side. So angle U is going to be equal to 120 degrees minus 50 degrees. So angle U is going to be equal to 70 degrees. If you're looking for another way to solve this triangle, there is a second method that we could do. And it would start by us finding this angle here, this interior angle. We can call it angle V. And what I know is that this exterior angle of 120 degrees plus the interior angle V, they are supplementary. These two side-by-side angles are located on a straight line. So together, they need to add up to 180 degrees. So I can start by finding angle V by subtracting 120 from 180. So to find angle V, 180 minus 120 is going to be 60. So we can fill that in our picture. And then what I do know about the inside of a triangle is that all three angles on the inside of my triangle, when I add them up together, they should be equal to 180 degrees. So if I know angle V is 60 and I know angle T is 50, I can simply just subtract these two known angles out from 180, and the leftover would be equal to angle U. So to find angle U, we have 180 minus 60 minus 50, and that's going to give us 70 degrees. So again, you can see that it doesn't matter if we used our first method, which used the exterior angle theorem, we got an answer of 70, or we could use the second method, which took 2 steps to get to the answer, but we still got an angle measurement of 70 degrees. In our next example, we're asked to find angle WXZ. So if I trace those 3 letters on my diagram, we have W, X, and Z. So they are actually asking us to find this exterior angle located at the top of the triangle. Now, what I see in terms of other angle measurements that are given to me, I have both exterior angles located here. So one exterior angle is 120 degrees, the second exterior angle is 140 degrees, and we're asked to find the third exterior angle. So we can use our sum of exterior angles theorem, because what we do know is that all 3 exterior angles, if you were to add them up together, it should total 360 degrees. So I can take these 2 exterior angles that were given to me, and I can simply just subtract them out from 360. The leftover would have to be equal to this missing angle, WXZ. So I've gone ahead and set up my equation. So we've got 360 minus 120 minus 140, and if I perform that subtraction, my angle would be equal to 100 degrees. In this question, we are asked to find the value of x in the diagram below. Now, this is a good question because it incorporates what you should already know about the side lengths of a triangle and how to classify a triangle based on side lengths, plus the information that you were learning about angle theorems. So we are given a couple of options. This is a multiple choice question. But what I'm going to do is I'm going to start by just redrawing my triangle. Sometimes it helps students to see the triangle kind of repositioned upwards. So if I redraw it, it would kind of look something like this. So the top angle, this top interior angle, this is 38 degrees. We're asked to find this angle in the bottom left corner, and they've put these kind of hash markings on the two sides. Now, if you don't recall, when you see these markings on the sides of any kind of shape, doesn't necessarily have to be a triangle, but if we see these markings on the side of our triangle, that tells us that both of these sides are equal in length. So this is in fact an isosceles triangle. It is a triangle that has two sides equal in length. So we need to use this information plus the information that we know about angles and angle theorems in order to solve for x. So because I know that these two sides are equal in length, that also means that these two bottom interior angles are also going to be equal. So if they've labeled this corner as angle x, let's say, then this right-hand corner is also going to be the same value. Now, we don't know what it is, that's why we're calling it x, so I'm going to place the same variable x in that corner as well. So if these two sides are equal, that means these two angles should also be equal. So what I do know about the inside of a triangle is that all three angles together are going to add up to 180 degrees. So what I'm going to do is I'm going to build an equation that I can solve for the variable x. So I know that 38 degrees plus x plus another x has to altogether be equal to 180 degrees. Now I know that I can take these two x's, they are like terms, so I can put them together. So 1x plus 1x is going to simplify to 2x. So I've got 38 degrees plus 2x equals 180 degrees. So again, what I can do is collect like terms. So I can take 38 degrees and bring it over to the right-hand side. So that's going to leave me with 2x equals 180 degrees minus 38 degrees. And if I do that subtraction, that's going to give me 142 degrees. And then simply to isolate for x, I'm going to divide both sides by 2. So that gives me a value of x equals 71 degrees. So angle x in the bottom interior corners of my triangle, each of them have to be equal to 71 degrees. And if I go back and look at my multiple choice option list, I can see that 71 is one of my options. So I'm just going to go ahead and circle our correct answer. In our final example, we are asked to find all of the missing angles in the diagram below. So we have a total of 4 angles to find. We have this missing interior angle. We're going to call it angle C. And then we also need to find all 3 of the exterior angles. So this is a great question because it's going to really put into practice all the different types of angle theorems. Plus, it's going to be good practice for you on how to label or properly identify or name all of the different types of angles in a possible diagram. So the easiest thing to start with would be to figure out what is this missing third interior angle, angle C. So again, we know that all 3 interior angles, when added together on the inside of a triangle, that's going to add up to 180 degrees. So to find angle C, I'm simply going to subtract the given angles from 180 degrees. So I've gone ahead and set up my equation, And if I subtract 180 minus 85 minus 50, I get an answer of 45 degrees. So I'm going to go ahead and put that into my diagram so we know what angle C is. So now we're going to go ahead and calculate all of the exterior angles. So let's go ahead and start with the exterior angle that is directly beside 45 degrees. So angle C, which we just calculated. So this exterior angle in this corner, let's figure out how we can name it. So remember, most angle names typically have 3 letters. So this exterior angle, we're going to assign it a name with 3 letters. So it doesn't matter which end you start with, as long as the letters are in the correct order, but we're going to start from this end here. So if I had to name this exterior angle with 3 letters, I would call it angle FCA. We don't need to keep going to angle D because remember, angle names only have 3 letters. We don't need to add that 4th letter. So we're going to call this exterior angle angle FCA. So in order to find this exterior angle, what I do know about it is that it is supplementary to angle C. So together with angle C, these 2 angles should add up to 180 degrees. So to find angle FCA, I'm simply going to do 180 minus 45, and that should give me that supplementary angle. So 180 minus 45 is 135 degrees. So I'm going to go ahead and put that into my diagram. Okay, I'm now going to move up to the top here, and I'm going to figure out this exterior angle. And to name this angle, it's going to be your choice, but I'm going to start at the top, and I'm going to call this angle DAB. So that is referring to this exterior angle here. So again, I know that angle DAB is supplementary with angle A. Angle A is 85 degrees. So together, these 2 angles should also add up to 180 degrees. So I've gone ahead and set up my little equation. So angle DAB is equal to 180 minus 85. And 180 minus 85 is 95 degrees. So I'm going to fill that into my diagram. So we have one final exterior angle to calculate or determine, and I'm going to choose to call this particular exterior angle, angle EBC. So there are 2 ways that we could choose to do this. We could continue using the same method that we've been doing for the other 2 exterior angles, because I know that angle EBC is supplementary with angle B. Angle B is 50 degrees. So together, these 2 angles should add up to 180 degrees. So that is one way that you can choose to calculate it. The other way you could also calculate your answer is knowing that the exterior angles, all 3 of them together, they should add up to 360 degrees. So knowing that, if I wanted to find the last remaining exterior angle, I could simply just take my other 2 exterior angles and subtract them from 360 degrees. Either way, I'm going to get the exact same answer. So just to change it up, I've decided to take my exterior angles of 95 degrees and 135 degrees and subtract them out from 360 degrees. Again, if you choose to use the supplementary angle method, you're still going to get the exact same answer. So if you perform that subtraction, you should get an answer of 130 degrees. So that is our final exterior angle, and we've found all of the missing angles from the diagram. So remember, one of the great things about questions involving angles is that there are multiple different ways to solve each problem, and so you're just going to go ahead and choose the method that works best for you.